Have a good day, everyone. Today I will discuss about mathematical preliminaries. Before we dive into probability, let's quickly review some fundamental mathematical concepts that will be essential. We'll be working with set, sequence, and series, so a solid understanding of this basic will make our journey smoother. This equation for mathematical preliminaries, so yun, A slash cap B is equal to slash curly bracket x slash mid x slash in a slash text plus curly bracket or curly bracket x slash in b slash curly bracket. The second is set interactions. A slash cap B is equal to slash curly bracket x curly slash mid x curly slash. This will be my second discussion. We'll go back to the sample space, defining possible outcomes. The very first step in building any probability model is to define our sample space. This is the set of all possible outcomes of a random experiments. It's crucial that the outcomes list to our sample space are both manually exclusive, only one can happen at a time, and collectivity exhausted, the sample space covers any possible result. So this is the equation of sample space defining possible outcomes. Sample space close and open parentheses slash omega colon slash omega is equal to slash curly bracket e
Go.
is equal slash curly bracket e underscore 1 comma e underscore 2 comma e underscore 3 comma slash dots underscore I slash curly bracket for a single coin flip slash omega is equal to slash curly bracket text curly bracket heads comma tails curly bracket slash curly bracket. For
What?
my,
Go.
for my third discussion is all about discrete and continuous. Sample space can be broadly categorized into two types, discrete and continuous. Discrete sample space involve outcomes that can be counted, while continuous sample space involve outcomes that can take any value within a range. So this is our the equation of discrete and the fourth discussion is all about assigning probabilities and actions. Once we define our sample space, that next critical step is to assign probabilities. For continuous space, we assign probabilities to subsets of the sample space called events. These probabilities assignments must be adhered to three fundamental rules known as the axons of probability. So this is the formula of assigning probabilities and the actions. So
Go.
this is my fifth and sixth discussion, properties of probability. This is the equation of properties of probability, probability of complement, probability of empty set, general finite additivity, probability of union to events necessary disjoints, union bound. This is my seventh discussion, discrete uniform law. A very common and straightforward probability law applies if all outcomes in a finite discrete sample space are equally likely. It's called the discrete uniform law. So this is the equation of discrete uniform law. Probability of each outcome. The second is probability of an event A. If event A contains K outcomes, then P closing open parenthesis A is equal to slash from closing open parenthesis K slash N is equal to So, this is my 8th discussion, continuous uniform law. Similar to the discrete uniform law, a continuous uniform law applies to continuous sample space where probability is proportional to size, often area or length. We'll use the dark example to illustrate. So this is the equation for continuous uniform law example dark on unit square. Probability of an event A. For my ninth discussion, countable additivity. When dealing with infinite discrete samples space, we need a stronger version of the additivity actions called countable additivity. This allows us to sum an infinite series for probabilities. This is the equation of countable additivity. Countable additivity action for a sequence of disjoints event A underscore 1, comma A underscore 2 slash dots close and open parentheses AE dot A close and underscore I underscore I got you. So, the last discussion is all about what is probability. So, probability is the behind that mathematical framework is important to understand the different interpretation of probability. It is about what will happen or what we believe will happen. Both views are viable. So this is the equation of probability, the conceptual representation of probability interpretation, the frequency interpretation